Alrighty, so we're starting the first video of the 10.3 notes. This will probably take multiple videos because 10.3 is the start of logs, or short for logarithms or logarithmic functions and inverses. So basically, what is a log? Well, basically, logs are what can allow us to find exponents. Basically, that's basically logs allow us to figure out exponents because, say, like an equation 2 to the x equals 6. I want to figure out what exponent of 2 gets me to 6. However, I mean, that's not exactly a nice number. Using logs will help us figure that out. All right, helping logs will figure that out. Now, just some kind of basic things about logs here is going from logarithmic form to exponential form, and then kind of going backwards. So when we write this out here in a log form, first of all, we write the word log, of course, just log. The number that is being raised to the exponent, not the exponent itself, but the number being raised to an exponent, is what we call the base number. So it's like log base 5. It's like a little 5. It's kind of like this little 4 down here, which we'll get to later. Log base 5. Now the big number in the equation is going to go right here. Log base 5 of 24, or like the equals number right here. And that is going to be equal to the exponent number itself. So log base 5 of 25 is equal to 2. If we do something like this, this is log base 2 of 32 is equal to, what's the exponent? 5. This one right here, log base 3, the number being raised, of 729 is equal to 6, what the exponent is. And this one, we could still even do it with fractions. Log of 1/2 of 1/8, so this 1/2 and this 1/8, and then that is equal to 3, okay? So that's kind of how we could write exponential, statements like this as logs, and we can also go the other way too. So this, when we write it like this is the same as this log 4 raised to that power. So 4 to the 4th power is equal to the 256. So basically, we're doing what we did up here, but kind of in reverse. And also, make sure that this is a true statement, okay? Like, actually, I'm going to go here. 4, raise that to the 4, I want to make sure that actually equals 256, and we can see right here that it does. We have this right here, log base 7 of 1 is equal to 0. That is the little number 7 raised to that 0 is equal to 1. And if you check that, that turns out to be true. This is 17 little number raised to the 2nd power is equal to 289. And then this one right here is the 8, raise that to the -2 is equal to 1 over 64. Okay, is equal to 1 over 64. Okay, so a couple things here. Now this is going to help us with calculators, what I'm about to write here. This will help you with kind of calculators. So a lot of what we will be doing with logs deals with kind of typing them into calculators and knowing how to type them into calculators. There is a way to do logs by hand. Well, there's some logs down here that we'll do by hand, but for the most part, we won't do that. Well, actually, not the ones that will be decimals. I'll explain later. So anyway, so what we write here is a common logarithm. This is common logarithm, and then this is going to be a natural logarithm, or a natural. We call them common logs and natural logs. Now, the reason for this is, if you have a log, say you have something like all of these logs up here have little numbers and a big number. But let's just say I have a regular log and a big number 17. I just made that up. That is the same as having a little number 10 right here as your base number, okay? So anytime that you see a log with no little number, you just have to imagine that there's an invisible 10 down there, all right? So like it's log, and then there's an invisible 10 that's being covered up of 17. And now natural logarithm, that is log that uses base e, log base e. If you remember, that's the number that is e is equal roughly 2.718, all that there. We're going to call that the natural log, and that is the same as just ln. So if you, and that one also is a calculator button as well. So so you will never see log base e. It will always be natural log. And same as you will never see log base 10. It will always just be log of 17. Now, how that helps you with calculators, most calculators, again, this is a TI-84, so it's a graphing calculator. Some of you might have this, some of you might not. But most calculators out there, you should see an LOG button and an LN button. So for that one that I talked about, if you're finding the log of 17, well, all I got to do is type log, do 17, close it up, click enter. That's what we have, okay? So that's your log. So that's the log of 17. Same thing, if I did the natural log of 17, just type that LN there, we'd get that right there. Get two different answers. Okay. Okay, so that's your common log, that's your natural log. Let's start evaluating some of these. All right, start evaluating some of these. I'm going to cross some of these out here. Don't want to work some of these out. So log of 2, base 2 of 16, and I need to figure out what number is that equal to. It's going to be equal to some number. I don't know what, but it's going to be equal to some number. Well, again, log base 2 of 16, and actually, if I were to write this as the exponential form, kind of like 5 through 8 here, that would give us 2 to some power is equal to 16. And again, it's that question mark power that I'm trying to figure out here. So we'll try to figure out 2 to what power gets you to 16. And again, that's kind of where you do a little bit of guess and check. 2 to the, hey, maybe 2 to the second. No, that's not 16. What about 2 to the third? No, that's not 16. What about 2 to the fourth? That's 16. So this log, since that exponent to get 2 to 16 is 4, log base 2 of 16 is going to be equal to 4. Okay? If we ask this over here, log base 30 of 30, that's equal to a number. What exponent of 30 gets me to 30? And we probably don't even need to test this one on a calculator. That should be 1. So log base 30 of 30 is going to be equal to 1. All right, so it's equal to 1. Now we go to these ones right here where we have fractions. Log base 2 of 1 over 4. Now again, this is asking you 2 and what exponent gets you to 1/4. Now exponents only, now the only way that you can use an exponent to get a fraction is if it's negative. So if this number is a whole number and this number is a fraction, or vice versa, it's automatically going to be negative. And at that point, you're now asking yourselves, okay, 2 to what power gets me to 4? We should all know 2 to the second power gets us to 4, and it's negative, so the answer to evaluating this one out would be -2. So again, if it's a base number and a fraction, base number's whole, fraction in the big number, we have a negative number. You say we go to this one, log base 3 of 1 over 27. That tells us it's automatically going to be negative. I ask myself now, 3 to what power gets me to 27? We test it. 3 to the second is 9, so that's not it. 3 to the third, if we tested that one out, is 27. So it's to the third power, but since it's a fraction, it's negative. So that would be equal to a -3 right there. Log of 100. Notice there's no little number down there. So we're gonna put an imaginary 10 down there. Now you don't have to do that. You can if you want, but you don't have to do that. Now there's 2 different ways we could do this. I'm going to do it by hand here. This is asking 10 to what power gets me to 100. So what power of this will get me to this? And again, you test your calculator out, and you can see that 10 to the second is 100. So it's equal to 2. All right, so this is equal to 2. Now you notice that this is just a log of 100. There's nothing else here. That you can type into your calculator. So log of 100, close that parentheses up. Hey, that's just 2. All right, so log of 100 is just 2. All right, so again, it gets the same thing there. So this one, if it's nice, you can do it by hand, but if it's not, you can just type it into a calculator. So with that being said, I just want to state that the ones that we've done so far, the ones that come out to be nice whole numbers, so like positives and negatives, The expectation is that you should be able to do those mostly by hand, all right? There is a way to do logs, all of these logs with calculators. However, the expectation now is that you should still be able to do this by hand. Now, we get down to natural logs. Now, natural logs I will not expect you to do by hand, because natural log of 100,000, you see that ln button right there? You click that, type in your 100,000, so that's one more zero right there. Close parentheses, and we have our answer, about 11.5. All right. So these ones are all calculator based, all right? It's all calculator based. You're just going to just type these all into a calculator. I'm going to do 19 and 20 just to show you how to type those ones in, because, you know, a fraction and then E, you just kind of want to show you how to type those, maybe type those in. So the natural log of 9, just type that in, just type ln 9, enter, that's easy. Now do natural log of 1 over 49. So that is the natural log. And anytime I'm doing a, hang on, don't do that extra parentheses there. Come on. Oh wait, hang on, I got to do this and delete it. Okay. So don't do an extra parentheses, just do natural log parentheses 1 over 49. So I'm going to do 1 divided by 49, and then close that parentheses up. We should get around this right here. Again, it's kind of similar. You had a fraction in here, so generally your number is going to be negative. So that gave us a negative 3.9 there. And then the last one, number 20, that's the natural log of E. So natural log, I'm going to hit the E button on this one. Again, that's the second E. Again, figure out how to do this. Figure out your E button. And then, since it's just natural log of E with no exponent, I'm just going to put to the first exponent. All right, if it's just natural log of E, just write to the first exponent. We're going to click that, and we're going to get 1. Now notice, natural log is the same as log base E of E. That equals 1. If we go up here, we notice that log 30 of 30 is also equal to 1. If you're noticing a pattern, I'm glad you are noticing it, because basically if log, and I'm just going to put a B down here and a B up there. If these two numbers are the same, your log is automatically going to be equal to a positive 1. Okay, so if this little number and this big number are the same, you're automatically going to be equal to 1. Okay? All right, so that is the first video of the 10.3 notes. I'm going to do the other video. I'm going to kind of separate this one from the other video. So just keep a lookout for that, and I'll be back to you soon. Thank you.